Okay, start chapter 11 today. Trip through geological time. Today's lesson, going over the geological time scale. But in the lesson, we'll know what exactly geological time is. Earth's history in one day. Suppose you can squeeze all Earth's 4.6 billion year of history into a 24-hour day. The table shows the times at which some major events would take place. For example, like at midnight, Earth appeared at midnight. 3 a.m., rocks appeared. 4 a.m., bacteria appeared. 2 p.m., algae appeared. 8:30 to 9 p.m., seaweed and jellyfish appeared. 10 p.m., land plants appeared. 11:39 p.m., mammals appeared, and at 11:58:43 p.m., humans appeared. It was the very last thing to appear on Earth. Okay, what is the geological time scale? We'll learn today. Think of the past. What names you use for different spans of time? Sure, we use hour, minute, century, decade, year, day. But the geological time scale uses longer periods of time. Because we need to develop a way to talk about that span of time. Because the time span on Earth's past is so great, geologists use the geological time scale to show Earth's history. The geological time scale is a record of the geological events and evolution of life forms as shown in the fossil record. I just first developed the geological time scale by studying rock layers and index fossils worldwide. Study rock layers, create the geological time scale. This information, scientists placed Earth's rocks in order by relative age. Later, radioactive dating helped determine the absolute age of divisions in the geological time scale. Figure 1 shows the earliest known rocks. These rocks here, the red ones, it's supposed to be the first known rocks still seen today. Divisions of geological time scale are used to date events in Earth's history. For example, Waxia is about 500 million years old. Velociraptor, here's dinosaur. It's about 80 million years old. 80 million years old Velociraptor. Smoldenin, it's like a saber tiger. It's about 12,000 years old. Time broken down to different periods. That's Cenozoic era. About 66 million years ago. 66 million years ago. That period of time, bacteria, Neogene, and the Paleogene was there at that time. Next, the Mesozoic era. Then Cretaceous, Jurassic, and Triassic periods. Yeah, we all heard that about in the Jurassic Park studying science. We've heard them time periods. Mesozoic era was about 251 million years ago. The Paleozoic era was about 542 million years ago. Precambrian time was about 4,600 years ago. 4,600 years ago, Precambrian time. By geological time. Geologists studied the fossil record, found major changes in life forms at certain times. They used those changes to mark where one unit of geological time ends and where one begins. Therefore, the division of geological time scale based on the events in Earth's history, showing major divisions of the geological time scale. Precambrian time. Geological time scale time begins with the longest span of time called the Precambrian time. Precambrian time, which covers about 88% of Earth's history, ended 542 million years ago. The fossils survived from that time period. 542 million years ago, there's still fossils survived from that period. Eras. Y'all just divide the time between the Precambrian time and present in 3 years time called eras. Alright, the Paleozoic era, Mesozoic era, and Cenozoic era. Periods are subdivided into units called geological time, called periods. Here, figure 2, Mesozoic era includes 3 periods: Triassic period, Jurassic period, and the Cretaceous period.
What?
Okay, we're back to it now. Okay, for example, the Cambrian refers to Cambria, a Latin name for whales. Rocks shown below are whales. Dark bottom layer dates from the Cambrian period. Okay. In this section we just went over, just know these here. If Earth's history took place in a 24-hour day, did mammals first appear?
11:39.
11:39 p.m. Correct. 11:39 p.m. Correct. Because the time span of Earth's past is so great, what do geologists use to show Earth's history? The geological time scale. Correct. Correct. Scientists first developed the geological time scale by studying what? Rocks. 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 Okay. Radioactive dating helped determine the age of the divisions in the geological time scale. True or false? False. That is false.
False.
Radioactive dating helped determine the absolute age. How many years ago was the Jurassic period? 200 million years ago. Correct. 200 million years ago. Correct. 200 million years ago.
200 million.
Yeah. How old was the Velociraptor? 80 million years ago. 80 million years ago. Correct. 80 million years ago was Velociraptor. Y'all just studied what? Fossil record. Fossil record. Correct. Fossil record. Y'all also divided the time between the Precambrian time and present time into 3 long years called what? Eras. Eras. Correct. Eras. Not years. Not times, days. Eras. Eras are subdivided into units of geologic time called what? Periods. Periods. Correct. Good job, guys. Now we go.
There's more. Oh.
There's more. Early Earth. How did Earth form? We all have the idea in our minds how Earth formed. Do we know the correct way?
Jesus.
That's a good idea. Hey, some people have that. Some people.
I think that Jesus made the world.
That's good. Good thought. I mean, but we don't. I'm not teaching in my book. Here's what we learn. We learn how Earth formed. Okay. Exploring life underwater. Dr. Anna Louise Wissenbach always loved water sports. She's always interested in organisms that live in strange, extreme environments. Now, as a biology professor at Florida State University in Oregon, she also gets to combine her 2 loves, learn about early life on Earth. Dr. Wissenbach uses submersibles or submarines. Studies bacteria that live deep under the ocean. Though sunlight reaches those depths, their hot water carrying dissolved minerals from inside Earth flows out through the vents. This material to make food, much as plants use the energy from the sunlight. Scientists think that these bacteria are Similar to what some of the Earth is, forms a life on Earth. That's the ocean that you don't see. Is like we can't go that deep. As a person, submarines maybe, but we can't dive down there and study this stuff. How did Earth form? Using radioactive dating, scientists have determined that the oldest rocks ever found on Earth are about 4 billion years old. 4 billion years ago. So, like the Earth we live on today is 4 billion years old. Way before we was ever heard of. The scientists think the Earth formed even earlier than that. So that proves it's 4 billion years old, but they think it's older than that. The age of Earth. For the scientists' hypothesis, the moon formed from material knocked loose from when a very young Earth collided with another object. The moon was part of the Earth. It was. It hit another object early in time, and a piece of the Earth came off the Earth and made the moon. So these Earth and the moon are about the same age. Scientists have used radioactive dating to find the age of moon rocks. Astronauts brought back to Earth. Most moon rocks are about 4.6 billion years old. Scientists infer that the Earth is about roughly 4.6 billion years old. Only a little older than those moon rocks. Earth takes shape. So scientists think that the Earth began as a ball of dust, rock, and ice in space. Gravity pulled this mass together. Earth grew larger, its gravity increased, pulling more dust, rock, and ice nearby. This ball of rock, ice, and dust is the ball we're walking on today.
Crazy.
It's very crazy that we walk in this Earth that was made by rock, and ice, and dust.
Rock, ice, and dust. So we're something frozen?
True, are we?
I don't know.
But isn't the Earth more hot?
It is very hot. We'll learn that. We'll
Because
learn
you
that.
think if it's ice and the sun's shining on it,
True.
it'll melt.
True.
So it'll, like,
Listen to this. It's even better. Okay. Energy from collisions. These two materials raised Earth's temperature until the planet was very hot. Scientists think that the Earth may have become so hot that it melted. This Earth melted. The first Earth melted.
I don't think that.
I don't know. They said the Earth melted. The ancient materials sank towards the center from Earth's dense iron core. Thus, this molten material hardened over time from Earth's outer layers, solid crust, and the mantle. Yeah. So the Earth melted sometime. At some point, yeah, 4.6 billion years ago.
and in 5 billion
Makes
years,
sense.
the black
Yeah,
hole.
yeah.
Makes a lot of sense.
Makes sense. I guess it does. We just listen to scientists. Okay. The atmosphere. Early Earth, they include light gases such as hydrogen and helium. The sun released strong bursts of particles called solar wind. Earth's gravity could not hold these light gases. The solar wind blew away Earth's first atmosphere. The first atmosphere, or atmosphere from the beginning of the Earth, blew away. So then, after that, after the Earth lost its first atmosphere, a second atmosphere formed. Volcanic eruptions and collisions with comets added carbon dioxide, water vapor, and nitrogen, and other gases to the atmosphere. Comet's a ball of dust, gas, and ice that orbits the sun. Kind of like the Earth. What? Dust, ice, gas. This is first second atmosphere here that they think it looks like, or looks like. For the oceans. At first, Earth's surface was too hot for water to remain a liquid. All water remained as a water vapor. The Earth's surface cooled, water vapor began to condense to form rain. Green water gradually accumulated to form oceans. Oceans absorbed much of the carbon dioxide from the atmosphere. continents. During early Precambrian time, much of Earth's rock cooled and hardened. Less than 500 million years ago, earlier, Earth formed. Rock at the surface formed continents. Scientists have found continents move very slowly over Earth's surface. Forces inside the Earth. Over billions of years, Earth's landmasses have repeatedly formed, broken apart, and then crashed together again. Early organisms. Scientists cannot pinpoint when or where life began on Earth. But scientists have found fossils of single-celled organisms, rocks that formed about 3.5 billion years ago. Earth's 4.5 billion years old, then 3.5 billion years ago, fossils found single-celled organisms. So, many years after Earth's formed. Scientists claim that all other forms of life on Earth arose from the simplest organisms. Figure 3 shows remains of organisms similar to those from other life forms. Bacteria Dr. Rosenberg studies are probably similar to these early organisms. About 2.5 billion years ago, the organisms began using energy from the sun to make food. This process is called photosynthesis. Heard about this? This is cool. Plants use photosynthesis. One waste product of photosynthesis is oxygen. Organisms released oxygen, the amount of oxygen in the atmosphere slowly grew. Some oxygen changed into a form called ozone. The atmosphere developed an ozone layer that blocked the ultraviolet rays from the sun. Shielded from the rays, organisms can now live on Earth. So, some of this Earth is pretty magical. They formed itself in ozone layer, blocked ultraviolet rays, and now we can live on Earth. Sure, me, what ozone layer just there burn up every day. Okay. Any questions about that? Earlier Earth? About 4.5 billion years ago, this was formed. Ice, dust, ice. Okay. We learned about Dr. Anna Louise Rosenbach. What does she love to do? What does she love? Water sports. Great. Water sports. Water sports. Water sports. Cold water carrying dissolved minerals from the inside the earth. True or false?
False.
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 Was it? Frozen water? Warm water. Correct. But the oldest rocks ever found on Earth. 4 billion. 4 billion years old. 4 billion years old. 4 billion. 4 billion years old. It's hard to believe, you know. According to scientists' hypothesis, how was the moon formed?
What they say.
From a black hole? We don't know that. Well, we learned that moon formed from material knocked loose when the Earth collided with another object.
That's what the scientists say.
What? That's what they studied, yes. Material knocked loose from the Earth. I think the Earth began as a comet and gravity pulled in together. True or false? False. I think the Earth began as a ball of dust, rock, and ice in space. Gravity pulled together. The energy from collisions with these materials raised Earth's temperature until the planet was very hot. Scientists think the Earth became so hot that it did what? Exploded?
No. Yes.
Yes. No, it didn't explode. They said earlier Earth first melted. That's what that is. Melted. It melted. Melted. First Earth melted. Earlier Earth may have included light gases, such as what?
Hydrogen and helium.
Hydrogen and helium, correct. Hydrogen and helium. Helium not going balloons blow up for birthday parties, helium? Walking on Earth, are there helium walking?
Put helium in balloons.
I agree, but are there hydrogen and helium? So water and
Air?
flame air. We're talking with a very high voice. I don't know. Where did you say that? Okay. What's the ball of dust, gas, and ice that orbits the sun called?
UFO.
UFOs. That's completely not right. Not right. We know this.
Sure.
Comets. 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 It's comets. On Earth, the ocean absorbs much of what in the atmosphere? Carbon dioxide. Correct. Carbon dioxide. Carbon dioxide. How long after the Earth formed was the rock on the surface formed continents?
500 years.
500 million years ago. 500 million years. 500 million years. Not billion. Million. Million. Not billion. Let's try billion. Now billion. Million. Who said the bacteria that are probably similar to early organisms?
Dr. Wynn.
Dr. Musk. That is not correct, but you know, he could do that. Elon Musk should be doing it. It's Dr. Razenbach. Dr. Razenbach, yes. Any questions, guys?
Back.
I think so.
Now we know how the Earth formed. We live on it every day.
Yep.